Hi everyone, here's a little robot I've been prototyping. It can move 2 servos, activate Neopixel LEDs, and power a board with a microcontroller on it, the ESP32. And it is being powered by 1.8 volts, which is boosted through this board, nicknamed Boostlet, up to 5 volts, or on this monitor specifically, it's about 4.78 volts. And that enables those 3 peripherals to be powered at about 5 volts, so that way they can work. So there's also this other board here, which is a connector board, so that way all of the monitors and meters can be connected at the same time. And there's also connections that go from here to the microcontroller board as well. So this is Boostlet, and I have a few variations of Boostlet. So this is another variation. This one has there we go. This one has PTCs connected as well, so that way it can have overcurrent protection. This Boostlet is one that I'm testing for different capacitance as well as different inductors for the boost converter integrated circuit. Which brings to the next topic. The IC that is being used here is called the PAM2401. One of the main reasons for choosing this IC is because it has a SOIC footprint, which makes it easy to solder by hand. And that was one of the key constraints for designing this boost converter. On Boostlet as well, there's logic level, actually 2 logic level converters to convert the signal for Neopixel LEDs from the 3.3 volt level to the 5 volt level, which it's being powered at. And that's done in consideration of when it's being powered by batteries. So on to the topic of batteries. If it's being powered by 1.8 volts, is it possible to power this robot from just 2 AA batteries? And the answer is we shall see. So I'm just going to connect that now. Place this like this, just temporarily. You won't be able to see anything. Okay. All right, the battery, the AA battery is now plugged in, and the robot is still working. It is moving the 2 servo motors, powering the adjustable Neopixel LEDs, as well as the microcontroller. It's outputting 4.77 volts, and that's monitoring the 3.3 volt rail, but we can monitor the voltage in to see how much power the battery is providing right now. So right now the battery is at 2.4 volts and everything is functional. We can stall the servos to see what will happen. A little bit of brownout there, but it returns to normal. Actually, was that brownout specifically, or was that just on the 5-volt rail? It does draw quite a bit of current from the batteries, or it does drain the battery a bit when that's happening, but it returns to normal. I've already created version 1.2 of Boostlet that I have to test, and this one has a new connection point for USB bus voltage from the USB-C connector there on the microcontroller board, and there is a selection sub-circuit on here that will choose whether to output the USB voltage onto V out, or to use output the boost 5-volt voltage onto V out. So that one will be next to test. Now, for boost converters, the inductor does play a role, especially for how much current is being drawn. So with this test Boostlet board, you can see I have these connectors to this inductor, and there are several different inductors that I have gotten ready to test and have tested in varying levels of microhenries. So that way this can be experimentally validated. Looks like we're running low on the battery there. This is Boostlet. It has solder bridge jumpers available to be able to bypass the PTCs, as well as to select if you want to use the 3.3 volt regulator for the VReg output, as well as if you want that 3.3 VReg output to be tied to VCC. On the back, there's various checkboxes that can be ticked or checked off depending on how the board is populated. And I added test points to this board, which you can see, so that it can be useful for looking at the waveform. The output is getting a little low from those batteries, but the servos are still turning and the microcontroller is still on. It's going to be fun to test this even more. The next step is to make a carrier board which would connect the microcontroller and the Boostlet together, as well as have connectors for the peripherals. There will also be additional sensors such as an ultrasonic sensor and an inertial measurement unit, an IMU. So that board will sort of also serve a purpose like this one is right now, but with even more connections. Okay, hope you enjoyed this preview of my new robot being tested. And there's Boostlet in action.